Merci, Monsieur le Premier ministre, pour cette feuille de route précise et ce soutien à l'ensemble de la filière. Comme vous venez de rappeler l'impact de l'activité humaine, notamment de la consommation d'énergie sur le changement climatique. Alors, précision sur les constats, précision sur les phénomènes observés, précision également sur les risques pour la santé, pour la nourriture, pour la sécurité, précision sur le coût, les conséquences de l'inaction, mais aussi toutes les solutions qui sont imaginées. Le docteur Rajendra Kumar PACHAURI est président du GIEC, le groupe d'experts intergouvernemental sur l'évolution du climat, IPCC en anglais. Il va nous donner toutes ces précisions. Je l'invite à me rejoindre ici. Et puis, comme Jean-Louis Ball vient de le rappeler, nous partagerons l'animation de cette journée avec un collègue animateur immortel. Et pour l'après-midi, je reprendrai place à ce pupitre simple mortel. Monsieur PACHAURI. And if you want the laser pointer, it's this one. Never press this one.
Bonjour, Mr. Jean-Louis Ball, Excellencies, distinguished ladies and gentlemen. Let me at the outset pay a tribute to the leadership of France and for their determination to bring about an energy transition, as His Excellency the Prime Minister just told us. It's not going to be easy, we all know that, and I can tell you that from my own experience, that change, even bringing the consciousness of knowledge into the minds of people, is not easy. And in that I'm reminded of what Mahatma Gandhi said. He said, at first they ignore you, then they laugh at you, then they fight you, and then you win. So I think this is clearly a transition that will happen irrespective of the problems and the hurdles that we're going to meet on the way. I'm going to give you a very quick PowerPoint presentation. And here I'm showing you the extent and the nature of the effort that goes into production of an IPCC report. Each of the 3 working group reports, as you can see, has a large number of scientists from all over the world. If you look at the total number, it's over 800 scientists who worked. And I'm not going to draw your attention to each one of these statistics, but let me just give you the last set of numbers given over here, which tells you that something like over 30,000 pieces of literature had to be reviewed, understood, and assessed in order to create the 3 working group reports. I'll now turn to the next slide, which tells you about what is involved in producing the synthesis report, which we brought out in early November last year. And this, of course, includes all the underlying material of the 3 working group reports, as well as 2 special reports that were brought out in the same cycle. One of them, incidentally, was on renewable energy sources and climate change mitigation, and the second had to do with extreme events. Now, we had a subset of all the authors that get involved in the production of the synthesis report. We had 51 members of the co-writing team, and they were drawn from 18 countries, and we believe that this is by far the most powerful report that's been brought out by the IPCC in its history. Let me go on to okay. There are 3 key messages that I'd like to bring to your attention. Human influence on the climate system is clear, and the more we disrupt, the more we risk severe, pervasive, and irreversible impacts as a result of climate change. But fortunately, we have the means to limit climate change, and to build a more prosperous, sustainable future. This is the point which both our speakers before me have made very effectively. I also want to tell you about what has happened during the period beginning the start of the last century and up to, say, 2010. The oceans have warmed and risen, the amounts of snow and ice have diminished, sea level has risen, and the concentrations of greenhouse gases have also increased. If you look at the topmost diagram over here, that gives you the extent of change in global average upper ocean heat content. The oceans have warmed right down to a depth of 700 meters, and that clearly has serious implications for marine ecosystems and marine life. And sea level rise in this period, beginning of the last century to 2010, has been around 19 centimeters on the average. This gives you the disposition of heat that's been generated as a result of climate change. And the point that I'd like to make is that more than 90% of the energy accumulating in the climate system between 1971 and 2010 has accumulated in the oceans. And land temperatures remain at historic highs, while ocean temperatures also continue to climb. Well, despite the fact that these are major impacts that are taking place, I'm afraid the record of human society in dealing with the problem and limiting increase in greenhouse gases has not been all that desirable. And you notice over here, in the period up to, say, 2000, the average increase in anthropogenic greenhouse gas emissions was about 1.3% per year. But since the beginning of the century, the average, if you look at this entire period, has been 2.2% per year. So therefore, we're really not limiting the increase in greenhouse gases. If anything, we are going counter to what is required. And there are extreme events which have increased in this period of time. It's very likely that the length, frequency, and/or intensity of warm spells or heat waves will increase over most land areas. In fact, under certain scenarios, we have projected that those heat waves which take place currently at once in 20 years will, by the end of the century, occur once in 2 years. I also want to highlight the fact that it's likely that the frequency of heavy precipitation events or the proportion of total rainfall from heavy falls will increase over many areas of the globe. So this is another form of extreme event which is going to increase in frequency and intensity. The impacts of climate change on agriculture are going to become progressively more negative. And in a world where population is increasing, you can imagine that has serious implications for food security. What you see over here are the positive impacts on the yields of certain crops and the negative impacts. The positive impacts are shaded as blue, the negative ones are yellow and brown. And you can see by the end of the century, the negative impacts are going to overwhelm the positive impacts, which result essentially from carbon dioxide being increased in the atmosphere and therefore photosynthesis becoming faster. So we are heading in this world towards a situation where clearly food security will be compromised. I also want to mention that throughout the century, climate change will lead to increases in ill health. Impacts on human health are going to be serious. There'll be greater injury, disease, and death due to more intense heat waves and fires. Undernutrition from diminished food production in poor regions. Please remember that there are small farmers all over the world who produce barely enough to meet their own needs. And therefore, if the impacts of climate change would reduce their productivity, clearly food security for those people in those communities will be severely compromised. And risks from food and water and vector-borne diseases will also increase. There would be impacts on human security because there'll be displacement of people in this century, particularly in developing countries with low income. There would be risks of violent conflicts by amplifying poverty and economic shocks. And there would be rivalry among states due to potential transboundary impacts of climate change, such as changes in sea ice, shared water resources, and pelagic fish stocks. So in other words, we are creating a society and we are creating conditions by which human society may have many more tensions than we see today. I also want to mention that climate change hazards exacerbate other stresses. The world has a lot of stresses, but climate change will only add to those stresses. There would be a slowdown of economic growth. It would make poverty reduction more difficult. It would further erode food security, as I mentioned, and it would prolong existing and create new poverty traps, particularly in urban areas and emerging hotspots of hunger. So these pockets of poverty will grow all over the world, not only in the developing countries, but also in the developed world. And I want to mention that since 1970 to the period 2008, of all the natural disaster-related deaths that occurred, 95% occurred in developing countries. So that clearly also highlights the inequitable impacts of climate change. Climate change impacts will not be uniform, will not be the same everywhere. Some parts of the world will suffer far more than others. And that clearly means that we may have a social order which is much more unstable than we have seen in the past. Now, climate-resilient pathways combine adaptation and mitigation to reduce climate change and its impacts. So we have to create this climate resilience if we want to deal with this challenge. Since mitigation reduces the rate and magnitude of warming, it also increases the time available for adaptation to a particular level of climate change, potentially by several decades. So the point I'd like to make is that adaptation alone will not work. We need a combination of mitigation and adaptation, because mitigation gives us the time, firstly, for greater levels of adaptation, and secondly, for being able to deal with some of the worst impacts of climate change, which in any case will be delayed or eliminated if we have adequate mitigation. What are the kinds of actions that are required to limit temperature increase to 2 degrees Celsius? Well, firstly, we know that we need a reduction of 40 to 70% in emissions by the middle of this century over 2010 levels. And we need a combination of adaptation and substantial sustained reductions in greenhouse gas emissions. This can limit climate change risks. And also implementing reductions in greenhouse gas emissions, of course, poses major technological, economic, social, and institutional risks. And I want to mention that the cost of mitigation is really not all that high. Yes, it is difficult, no doubt, but it amounts to no more than 0.06% of loss in GDP on an annual basis. And think of the cost of inaction. The cost of inaction means very serious impacts of climate change, and some of which I have already described. But of course, time limits me to going into these in detail. However, we have documented these very carefully in the 5th assessment report of the IPCC, and I would request this distinguished audience to go to our website, look at the summary for policymakers of the synthesis report, as well as of the other working group reports, and you would get a lot more information. I want to highlight the actions that are required for mitigation. Sorry, the electronics are not working. It works now. We need more efficient use of energy, greater use of low carbon and no carbon energy, and of course this is where renewable energy comes in. We need many of these technologies which already exist today. And I want to highlight one very important fact. If we have to limit temperature increase to 2 degrees Celsius by the end of the century, then we need nearly a quadrupling or trebling at least of zero and low carbon energy supply from renewable sources by 2050. So this is really the challenge that you have before you. And I'm very happy to see that a country, an industrialized, responsible country like France, is focusing so much on bringing about an energy transition. We need improved carbon sinks. This means reduced deforestation and improved forest management and planting of new forests. Bioenergy with carbon capture and storage would also be an option. And most importantly, as was indicated by His Excellency the Prime Minister, lifestyle and behavioral changes. Now, I want to mention that often you get the argument that renewable energy is going to be very costly. But we brought out a special report in 2011 which shows, as is seen over here, that in a number of applications, renewable energy is already economically viable. What you see over here is the yellow band, which indicates on the left the cost of conventional sources of energy, and red, green, and other bars that are shown over here give you the range of costs of renewable energy for those particular applications. And you would see in several cases there is an overlap. That means renewable energy is already economically viable, and therefore, at least in those applications, we should use it effectively. I will be giving the organizers a CD for a 3-minute film, which I hope at some stage during the day can be played, because that shows a major program that my institute has launched called Lighting a Billion Lives. There are 1.3 billion people in this world who have no access to electricity. Now, we cannot wait till grid-based electricity reaches them. Maybe 3 generations will go by before that can happen. However, with renewable energy being economically viable, we are spreading this on a large scale, and almost 3,000 villages have been covered in India and Africa. So I hope at some stage during the day that video can be played. Oops, sorry. I skipped. Yeah, this is a. Of course, there are huge co-benefits from reducing emissions of greenhouse gases. There's improved energy efficiency, greater energy security. There are cleaner energy sources. There's air quality improvement, and therefore benefits to human health, and reduced energy and water consumption in urban areas. You have much more sustainable agriculture and forestry, protection of ecosystems for carbon storage. And I also want to mention the fact that climate change and sustainable development have a huge overlap. As a matter of fact, a stable climate is an important component of sustainable development, and limiting the effects of climate change is necessary to achieve sustainable development. You also need to design effective climate policy in such a way that it mainstreams with development policy, and that provides us with sustainable development strategies. And it is important that we have options for equitable burden sharing, because that can reduce the potential costs of climate action to constrain development. So in other words, globally, we have to come up with a cooperative arrangement whereby we can have everybody pitch in, because that will give us economies of scale, that will give us much lower costs, and that, I think, is the order of the day. Now, today we have enough knowledge to be able to deal with this problem, and I think this is where Albert Einstein was absolutely right when he said, problems cannot be solved at the level of awareness that created them. Fortunately, we have the benefit of knowledge, including whatever has been produced by the IPCC, but new knowledge is also being created by renewable energy industries, by governments, on the basis of which I'm sure if we take a rational path forward, then clearly we can meet the challenge of climate change by bringing about very sharp and rapid and adequate reduction of greenhouse gas emissions. I'm very grateful for this opportunity, and thank you very much. I wish you all the best.